All right, welcome. This is week 14. Homework solution here. We have Tuesday, November 5th. The first one, it says study these two relations. F of x equals to 5x minus 3 and g of x is equal to 5x. Select all the statements that are true. Very easily, let's just graph it on Desmos and let's see. Okay, so first one, I said f of x, right? Type it in exactly the way you see it. 5x minus 3. The other one was g of x is equal to 5x. Huh, that's very interesting. Looks like it's almost the same. Huh, interesting. Do both relationship have the same slope? Let's see. 1, 2, 3, 4. Up 4 across 1. 1, 2, 3, 4 across 1. Yeah, they do. They do have the same slope. All right, let's see. That is check here. And that also makes sense because the slope is the number in front of the x. So here we would say, yes, they have the same slope. M is equal to 5. That is the slope. Both relationship intersect the y axes at the same point. No, that makes no sense. The blue one, which is g of x, intersected at 0. And the f of x, which is the red, intersected at -3. Nope, this is wrong. So we would say no to this one. All right. Why? They have different y-intercepts. Okay. For both relationship, the values of the output decrease as x increases. Let's see if that makes sense. Let's take a look at the graph. The value of the output, which is y, the output decreases. No, the output actually increases. Look, the output, which is the y value, is increasing over time. Okay, so this is wrong. This this is a really weird question of the third one for both relationship, the value of the output decrease as x increase. This basically just asks is saying the slope is it the value of the output decreases. The slope is decreasing. That's what it's asking. Decreasing. Right? That's what this question's asking. The slope is decreasing. And is that true? No, that is not true. For the relationship, the value of y is the same at when x equals to 3. Let's take a look. Where is x equals to 3? Let's see. X equals to 3. Are they at the same spot at x equals to 3? Let's see. X equals 2. X equals to... I can make it bigger. X equals to what? 3 is right here. Right there. Right here. Follow this up. Are they the same point? No, they're at different points. Nope. This one is also wrong. Okay. So this one is also wrong. Right? So only the top one is correct. Okay. The table below represents a relationship. Select all statements that are true. This should be rate. The rate of change for the interval show is constant. So the relationship is nonlinear. No, this makes no sense. Okay, let's just find the delta x and let's find the delta y. Okay, it might make a little bit more sense if we just write it out. Okay, so so it goes from 1 to 2, from 2 to 3, and 3 to 4. Our delta x is equal to 1. Okay, we could do the y now. 1 to 8 is what? Plus 7. Then 8 to 27 is what? Plus 19. Oh man, I might even need a calculator for this one. Hold on. Let's just go to Desmos calculator for this one. What is that? 64 minus 27 is 37. Huh, that is very interesting. Okay, this is what? 27. Huh. Delta y. Right? This should be a delta. Delta y is not constant, so it's not constant. There is no constant delta y. So the rate of change for the interval is constant. Nope, that is a false statement. Okay, the rate of change is not constant. Look, it says not constant here. The rate of change for the interval show is not constant. That is true. So the relationship is linear. That is wrong. That's the wrong conclusion. The rate of change for the interval is constant. Is it constant? Nope, that's wrong. The rate of change for the interval is not constant. Correct, not constant. So the relationship is nonlinear. That is true. Remember, remember, by definition, if the rate of change is not constant, it is nonlinear. That is the definition of something being nonlinear. Okay, the rate of change is not constant. Okay, which equation here can be written equals y equals mx plus b? Select all that apply. Please remember, this is y equals mx plus b is the only one that is linear. So take a look. Which one is linear, right? Is this one linear? Is the first one linear? Yes, exponent of 1, x and y. So this can, because this is linear. All right. Again, because it's linear. Next one, 1/2 x plus 3/4 y equals to 1/4. The fact that it's a fraction doesn't mean anything. It is still linear, right? There's an x and a y, and the exponent here is 1, so that is linear. 1/3 y plus 1/3 x squared. Oop, you see the squared? That is a problem. Do you see the squared here? That's a problem. Okay, this one is actually non-linear. That's why it wouldn't work. 4 plus 4x equals to negative 2y. Yeah, that works. That is a linear one. Okay, exponent here is 1, and there's only an x and a y. So this one is linear, so this one can work. Okay. So explain how you determine if equation is linear or not. Again, our two criteria, if you watch Monday's video, are, okay, there are two characteristics. Okay, there are two characteristics. I do not know how to spell that. Characteristics. I know it's spelled wrong. The first one would be, for it to be linear, again, the exponent, it is only 1. No more, nothing more or less. All right, the exponent has to be 1. I know it's spelled wrong. The exponent is spelled wrong here, but you know what I'm saying. And the second one, for it to be linear, right, there is only two variables, x and y, and no other terms like xy or z. Okay. All right, that should be less, no more or less. All right, there you go. Those are the two characteristics that you need to know to see if it's linear. If it breaks this, it becomes nonlinear. Okay, there you go. Those are all your homework solutions for Tuesday, November 5th. Sorry for the misspelling on these questions.